Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 105th of physics, and in today's lecture we are going to talk about the electroscope. Now, electroscopes are devices which is used for the detection of charges. First, we are confirming through electroscope that whether charge is present on a device or not. If it is the case, then we have to differentiate whether the charge is positive or negative. So we will discuss all these things in today's lecture, but let me first tell you that what is gold leaf electroscope. The gold leaf electroscope is a sensitive electroscope type that is used for detecting the charges. It consists of a brass rod with a brass disc at the top and at the bottom. There are two thin gold leaves in the form of foils. In order to keep the rod in place, the rod travels through the insulator. Let us discuss this structure first in detail. In the picture, you can see that there is a brass cap here in this case, and this is also known as the brass disc. As you can see in this picture, that this is in the form of a disc. So the real picture which is present in the laboratories of physics, you can see that this is in the type of a disc, so that is why it is called brass disc, and it is made up of brass, so that is why it is called brass disc. Then there is an insulator. Now, what is the need of this insulator? To keep this brass rod intact, and it shouldn't shake, vibrate, so it is passed through an insulator, and you can see that insulator in real here. So this is an insulator. And then we are seeing that this brass rod is going all the way to the bottom, and till here it is the brass. Now there is a gold leaf foil here at the bottom, and there is a brass plate. This is a brass plate, and this is a gold leaf foil. And sometimes we have to take the advantage of this earth. You will see in a moment there is earth as well. So figure shows the structure of a typical electroscope used for detection of charges. Not only for the detection of charges, and to test for the sign of the charge as well. Sign of the charge mean that whether there is a positive charge or negative charge or there on the rod. So first we are going to discuss how to detect the charge. This is very important. We are not detecting the sign of the charge. In this case, we are only detecting that whether a rod is charged or not. So in the figure, the gold leaf is close to the brass plate, as you can see in this photograph. It means that they are electrically neutral. There are positive charges and there are negative charges. Before the detection of any charges, these gold leaf foils are in collapsed form. So it means that they are neutral. It is in a collapsed state. The brass cape, brass rod, brass plate, and the gold leaf are electrically neutral. What does it mean? It means there is no excess of charge. So when a charged insulator such as positively charged glass rod, as you can see in this case, is brought nearer to the brass cape, the free electron from the brass and gold part of the electroscopes are attracted to the brass cape. Now there is negative charges here and negative charges are here. So when positively charged glass rod is brought nearer to the disk, because positive charges are attracting the negative charges and repelling the positive charges. So this positively charged rod will attract not only these electrons but also these electrons as well, and will repel these positive charges downward. So as a result, you can see that only positive charges are here and negative charges are here. We will see that first the gold leaf foils were in the collapsed form because they were electrically neutral. When both the foils become positively charged, then they will repel each other, and in this case you will see that there is a repulsion between the two foils. When you are seeing this state, then it means that the rod is charged. We are not concerned right now in this topic with the whether it is positively charged or negatively charged. So only we are detecting that this body is charged. So when they are attracted to the brass cape, leaving the brass plate and gold leaf positively charged, this causes the gold leaf to diverge due to the repulsion between like positive charges, as shown in the figure. In this way, we can conclude that the glass rod is charged. So that was the first part of detection of charges. Now we are turning our focus to another very important aspect of this gold leaf electroscope, and that is testing for the sign of charge, which is the next very important aspect of these electroscope. So for the testing of sign of the charge on the charged bodies, first we detected that the rod is charged by observing that the gold leaf foils are expanded. Now our concern is that whether that rod is positively charged or negatively charged. So in case of to test for the sign of a charge on a charged body, we need to charge the electroscope first. As you can see in this picture, that we are bringing or sliding a negatively charged rod at the brass surface. So they are all negatively charged. You can see there is negative charge there is negative charge and there are negative charges are this. So it means that we have first charge the electroscope negatively, and that is through the induction method. The electroscope can be charged easily by induction method. Now we discussed that in the previous lecture. If somebody is new to my channel, then you can go back to the previous lecture and learn that what is the charging of a rod by induction. And it is also my request to subscribe to my channel as well. Okay, the following diagram, which is shown next to the uh, charge electroscope, show the sequence of charging the electroscope positively by induction. Now you can see that there is a negatively charge, so whatever charges are in the form of positive will be attracted, and the negatively charged uh, bodies will be repelled. So you can see that positive charge. Now we have to remove these charges. So for that particular purpose we are taking the help of the earth. And when the earth is there, so negatively charged will flow to the earth, and only the positive charges will remain, and they will expand the gold foils. So it means that if they are expanding, then they are positively charged. Because we brought a negatively charged rod and the gold foil are expanded, so it means that positive charges are there, because the rod we already know that they are in the negative form. So this will not be negative, because the negatively charged rod will repel positive charges to the bottom of these gold leaves foil. So in this case we can see that you observe that the positively charged gold leaf foils will repel each other, and we can see that there is a positive charge as well. So we can detect generally like this, that there is a positive. To charge the electroscope negatively, this is very important part, we can slide a negatively charged rod on the brass cape of the electroscope as shown in the figure, so that some electrons from the charged rod can be transferred to the cape, causing the gold leaf to deflect or diverge. That was the main theme, how to test for the sign of the charge. So now we are generalizing this concept to detect negatively charged bodies. If a charge rod with an unknown charge is brought near to the negatively charged electroscope, we want to find the charges on a rod which is unknown, and we already know that the uh, electroscope is negatively charged, and there is an increase in the divergence of the gold leaf. So we can conclude that the charge on the charge rod is negative. So it means that if there is a divergence of the gold leaves and the electroscope is already negatively charged, so it means that that rod is also negatively charged. because they are diverging. That rod is diverging the gold leaves. So here you have to keep this in mind. Let us understand this positive charge detection as well. In similar fashion, we can detect the positive charge as well. How? If a charge rod is brought nearer to a positively charged electroscope, in the first case it was negatively charged and they diverged it. But if we are bringing the positively charged rod, and you know how to charge a rod positively, we discussed that few lectures back. You can go back and learn that. And the divergence of the gold leaf increases, we can conclude that the charge on the charge rod is positive. Electroscope was already charged positive, and when we brought that rod and it is increasing, diverging the gold leaves from each other, then we can conclude that this rod is positively charged. So in this way we can detect that whether the rod is positively charged. In nutshell, I can tell you that if an electroscope is negatively charged and you are bringing a rod with a negative charge, so excess of negative charges will repel the gold leaf foils, and we will conclude that the rod is negatively charged. Similarly, if the electroscope is positively charged, and you learned in the previous topic that how to charge electroscope positively or negatively, as you saw in this case, that how to charge the electroscope, which is written in the blue. So now we can generalize that to the negative or positively charged objects. Dear learners, if the electroscope is positively charged and you are bringing a rod which is unknown, and you observe that there is a greater divergence in the, because the electroscope is already charged positively, so there will be a divergence, but that will be a smaller one. But if you are bringing more charges in the case of rod, then the divergence will increase. Then it shows that that rod is also positively charged. But if the gold leaves are collapsing, then it means that you can understand that this rod is negatively charged. But if there is a divergence, then it means that positive charges are repelling each other, so that rod is also positively charged. Note that for both cases of testing the sign of the charge, only phenomena of repulsion between like charges is used. Do you know why attraction between unlike charges cannot be used to test the kind of charge? I am leaving this question for you people. My question is that we are using the similar charges, like charges, for the detection of charge. Why we are not using the unlike charges uh, for the test of the kind of charge? Write the answer in the comments, and then I will discuss it with you and I will answer you. That's it for today. Tomorrow we are going to discuss a very important topic that is very vastly used in the field of electricity as well as in magnetism. So for tomorrow, leave it for tomorrow and stick to this channel for that very important topic. Thank you very much for your time. Allah Hafiz.